We're going to do a quick round of introductions for both myself and Joe. We'll get into a presentation from Joe around cloud strategy and stats, and then we'll have some time at the end of our webinar for about probably 10 or 15 minutes of questions. So introductions will be very quick. Joe's presentation will run 20 or 30 minutes, and then we'll have some time for Q&A. So just before we get into everything, let's just do a little quick round of housekeeping. So because this is a one-to-many sort of medium, your microphones are muted, so feel free to make noise and move about as you want. You definitely won't be interrupting our flow of the webinar. But having said that, we do want your participation. So if you wouldn't mind posting your questions in the questions panel of GoToWebinar, my friends at Newvem will help sort of curate those and bring those to my attention when the time is right, and I'll make sure we get to just as many of those as we can. The webinar is being recorded, so the Newvem folks will follow up with participants on sort of how to see this webinar again. So with that being said, let me introduce my fantastic guest for this panel, Joe Weinman. Joe is Senior VP at Cloud Services and Strategy over at Telx, and really if you've been following cloud computing trends or news at all, you probably already know Joe's name. In addition to his role at Telx, he's an author of a book called Cloudonomics, where I think he'll tell us exactly what the goal of that book is, but to me it seems to be to bring some economic justification to different areas of cloud computing. So he's going to lead us first through a presentation focused around cloud strategy and statistics, and then we'll come back and we'll talk about how that all relates to how we like to accomplish things in the cloud. Just one moment here. I think I had Joe on mute, but he's not anymore. All right.
Can everyone see my screen?
Yeah, we can see it. Just
can anyone see my screen?
Yeah.
Yes? Okay, good. So hello, everyone. I'm going to talk first about one of my favorite topics, which is cloud and IT strategy, because I think too many people delve right into the technology, and I want to talk about the strategic use of cloud, and then I want to go into some of the work that I've done around fairly rigorous viewpoint regarding the statistics of public clouds, as well as where the economic break-even is. And the punchline of both those topics is, hey, guess what? Cloud is actually a good idea. And the second punchline is, hey, guess what? Hybrids are a good idea. Everyone's talking about hybrids now, but I did the proof of this about 5 years ago, showing why hybrids are inevitably the best approach for most enterprises. So without further ado, let me try and jump into things here. A little background on Telx. For those of you in the U.S., we're basically a national data center co-location and carrier-neutral interconnection provider. A lot of the major cloud providers of various stripes use our facilities, as well as other companies like financial firms and media and entertainment companies and so forth. So that's enough about Telx. As Patrick mentioned, I collected all the stuff that I've been sort of putting out in terms of white papers and apparently random remarks at various events, and wrote this book. And I'm going to give you a little bit of a preview of part of Chapter 4 on strategy, and then some snippets of other chapters in the book that cover both the variety of uses of cloud and, again, the mathematical justification for a variety of cloud architectures. So the first thing I want to cover is the range of IT value. As it happens, this month is the 10-year anniversary of a book called Does IT Matter?, which is a actually toned-down version of a Harvard Business Review paper or article called IT Doesn't Matter, in which Nick Carr observes that because IT is becoming a commodity, and some people would argue that the cloud is hastening that therefore it can't deliver any strategic advantage or competitive differentiation. And my observation would be that there's a range of IT, and there are certainly tactical systems that, in that family I would include things like expense reporting and procurement systems, or as I like to call them, paperclip ordering systems, and things like that, that probably don't provide much competitive advantage. It's hard to picture someone as a CEO making the cover of Forbes or Fortune and saying the reason for my success is we really focused early on easier and cheaper paperclip ordering, and we were able to parlay that into global dominance. But at the other extreme, from tactical and even operational systems like supply chain management, we have a couple of types of IT that I would consider to be strategic and maybe even existential. And to cover existential first, what comes to mind is Borders Books and their former battle against Amazon.com. Of course, Borders had the brand, had the deep capital resources, had the national footprint. Amazon.com was a scrappy upstart, which originally, just sent out some emails and plain text, had a very simple website, et cetera, and obviously has grown substantially since the first few days of operation. And to Borders, the ability to sufficiently leverage IT became ultimately an existential issue. And I mean existential here in the dictionary sense of pertaining to existence, not in terms of the Jean-Paul Sartre philosophy. And they no longer exist due to a failure to sufficiently exploit the inherent capabilities that IT very broadly and the cloud in particular offered. And I would also argue that for a number of companies it may not be an existential issue, but it's certainly a strategic issue. In other words, it's a boardroom level type of technology slash business model enabler slash business transformation enabler, whatever you want to call it, that ultimately can be relevant to competitive differentiation. And, if you don't believe any of this, we can look at some specific case studies. This slide from Mary Meeker basically shows on a log scale, so this is not a linear decline, but an exponential decline of the Encyclopedia Britannica print edition. Shows sort of that it was flat for a number of years until, the desktop version of the encyclopedia became available in effect through Encarta, and then the online version of the encyclopedia became available through Wikipedia. And try as Britannica might with sort of a online version, they certainly had trouble competing against these major technological disruptions. And so you can see the steady decline beginning with Encarta, and then you can really see the growth of Wikipedia relative to that, ultimately culminating in at least the end of the print edition. And then, it'll be interesting to see whether the open source version of encyclopedias in the style that Wikipedia has fostered relative to the curated and edited version that Britannica has continued with, ultimately, which one will succeed. And I think we probably all have our own views on that, but to be fair, we'll see exactly how it turns out. So Mary Meeker calls this reimagination, and reimagination, to put it bluntly, is maybe more appropriately described as the creative destruction of entire industries, or massive transformation and upheaval, or the death of all we hold near and dear, or whatever we want to call it. But basically, this ultimately has to do with the creation of new business models and companies, and the end of the existence of others, or at least of their traditional business models. And of course, it isn't just encyclopedias. There's lots of other industries that have undergone that, including, take your pick, printed photos, a lot of the traditional, Kodak or maybe even Polaroid version, et cetera. So to turn to the strategic version of this rather than purely existential, one thing that we could do is we could say because we are all on this line interested in the cloud, we have a self-interest in saying that cloud is kind of a good thing, and being strategic kind of sounds important, so let's take the benefits the cloud offers and claim that they're strategic and be done with the question as to whether cloud is strategic or not. I think that's sort of begging the question and is a circular argument, so I think it makes more sense to say, how would we know that something is strategic? And one way that we might know it is to first adopt some sort of strategy framework. And one that I've come to know and love is called The Discipline of Market Leaders by Tracy and Wiersema. And this is actually a book that dates back to the mid-90s. And so it wasn't really written with IT in mind or the web paradigm in mind. It was just oriented towards how can companies actually be differentiated, and their conclusion is that there are three major ways that companies can do that. The first one is through operational excellence. So, for example, it might be viewed more simply as better processes, but either faster, cheaper, higher quality, something that basically was an internal focus on better manufacturing for product companies or service delivery for services companies, but in any event, it's all about improved operations. And so things like statistical quality control and process improvement, Malcolm Baldrige National Quality Award, all those things were kind of relevant at the time. But good example of a company dating from that era might be someone like Walmart, who certainly grew from a corner store to the #1 retailer globally by improvements in things like cross-docking and also, to some extent, although it's later than the book, applying technologies like RFID and Walmart Connect. Another good example is product leadership, and you could look at things like the first in any category, the first canned tuna fish, the first pasteurized milk, the first service that provided jets rather than propeller planes, et cetera. And so there's certainly ways to innovate in products or services and therefore be different. Yet another example of a way to achieve some degree of differentiation is through better customer relationships, which Tracy and Wiersema call customer intimacy. And even if your operations aren't that good and your products are me too, if you can have those tighter customer relationships and move away from being transactional into understanding customer needs better and fostering customer loyalty. And at the time the book was written, that would include things like having customer support teams on site. And some people would argue that a very large computer company at the time that's still around may not have necessarily been a product innovator, but that they, by having those deeply intimate relationships, were able to become the #1 computing vendor and ultimately leverage that into more of a services model. Besides their three value disciplines, as they call them, to me there seems to be a fourth one, which is sort of a meta-discipline, which is accelerated innovation. So the ability to improve operations better than anyone else, or continually introduce new products better than anyone else, would seem to be a way of always, again, excelling. And we all know companies that fall into those categories. So if those 3 or 4 value disciplines ultimately are, high-level generic strategies, the question then is, how does that apply to IT and the cloud? And there are, I think, several ways in which those can occur within a cloud context. Operational excellence, what comes to mind there is someone that leverages the cloud, big data, and mobility to, for example, optimize a field support force or logistics force by taking real-time traffic data and feeding it into some big engine in the sky, and then convolving that against independent lists of customers that need to be visited based on their 2-hour support SLA, or packages that need to be delivered based on their guaranteed delivery by 10:30 SLA, and therefore do all that kind of optimization and ensure that basically there's enhanced customer loyalty, fewer missed SLAs, lower fuel costs, etc., and thereby provide a higher degree of operational excellence. In product leadership, if we think about something like the iPad or the iPhone, those are certainly, when they were introduced, unique products that led the market. And actually, it wasn't the product so much as an ecosystem that included things like the App Store and a type of hybrid. For example, let's say Siri, where there's functionality in the endpoint device as well as in the cloud, as well as an entire ecosystem of providers, including online services, which could include things like social networks. And then in terms of customer intimacy, I think of companies like Amazon.com or, let's say, Netflix or Pandora, that really, it's not so much the traditional model of having 50 people on site at the customer and jointly developing new solutions, but more this notion of looking at information from millions or tens of millions of customers, and then working that all using advanced algorithms like singular value decomposition, like the Netflix Cinematch algorithm, and then ultimately determining movie recommendations, or in an Amazon.com sense, people who bought this also like this, and so forth, to be able to provide recommendations, again, enhancing customer relationships and reducing customer churn and maximizing customer satisfaction and thus total customer lifetime. So on accelerated innovation, there are a lot of companies using the cloud and contests for open innovation. So enough about that. I want to talk now about some stuff beyond IT strategy and cloud strategy into some specific performance characteristics about clouds, including public clouds and hybrid clouds. And I want to get into some of the math behind that. And the first thing I would say is that everyone has seen the NIST definition of cloud. My only problem with it is that it's so long that you can't even fit it onto a single slide. So what I did is came up with a slightly shorter definition where it's semantically equivalent to the NIST definition, but it basically is just a acronym where a cloud is a common location independent online utility available on demand. Common in the sense of shared resources, whether across business units for a private cloud or actual legal entity customers for a public cloud. Location independent, it shouldn't matter where you are to use it, and it shouldn't matter where the actual cloud is physically resident, as long as response time SLAs are met, whether it's for infrastructure as a service or for SaaS functionality. It's online, in other words, broad network access. It's a utility, in other words, a measured service slash pay-per-use slash linear tariff, and it's on demand in the sense of on-demand resources, and obviously there are a few variations of that. Now, besides being a clever acronym, I've worked out a lot of the math behind this. So there's a reduction in penalty costs due to under or overutilization of resources for independent demands, which I'll get into a little bit more, but it's basically that inverse square root function. It's location independent, but there's some interesting trade-offs between the number of nodes deployed versus the response time. And the formula on a plane is simply 1 over the square root of n. The formula on a sphere like the Earth has a slight trigonometric adjustment, which increasingly or decreasingly matters. It's online, so there are some characteristics regarding both capital investment trade-offs as well as latency penalties. So there's a trade-off between a hub/mesh architecture versus a hub architecture, and obviously a mesh is in between that. I've also characterized the improvements possible due to smart networks like SDN/OpenFlow/ OpenStack quantum network as a service type of capability, which I won't get into, but they exist. All this stuff is online, by the way, if you want to dig in further. I will get into this utility math that shows why and when hybrids are best. And if we have time, which I don't think we will, there's some equations regarding the importance of on-demand resources and provisioning interval reduction as far as that are dependent on the application profile. So to cover some of these in a little bit more depth, I won't get into axiomatic cloud theory, but those of you that are hardcore math geeks, you can look into this. It's a extremely theoretical but useful formulation that I made of cloud that basically provides a strong foundation for the equations, but I'm going to skip straight to some of the theory around why all this stuff is important and why hybrids are key. A lot of people talk about economies of scale in the cloud, and you end up with sort of a notion that looks like this, some diminishing returns to scale, but if you look at a typical unit cost for a server hour or a gigabyte month or you know, a megabit per second of bandwidth or whatever you want to consider, you end up with something that looks like this. If you're a consumer, you know, you don't have purchasing power, you don't have scale economies due to operations and so forth. And so the larger and larger you get, you end up with a unit cost that looks something like this. Now the problem is you can't just look at the economies of scale, because there are also some costs that are scale invariant and some areas where there are diseconomies of scale. But even if you look at all of that, you end up with a curve that still shows that, you know, large clouds can do things at lower cost than even well-run enterprises. The interesting challenge comes in, though, when we consider just not the cost structure, but the delivered price. And the delivered price actually leads you to the fact that anyone that is running a commercial business also has SG&A and other additional cost structure elements that include things like the fact that, you know, they're in business and therefore they're out to make a fair or an unfair, even perhaps, return on investment, and they also have issues like uncollectibles and you know, accounts receivable where there's additional costs that need to be carried, et cetera. And so it's probably likely that a large cloud service provider still does better than a consumer, but it isn't immediately obvious that it will necessarily have a lower unit cost than a well-run enterprise. And in fact, a lot of the data out there shows that on a unit cost basis, those companies that are, you know, well-run, have the latest tools, latest processes, know what they're doing, can actually deliver infrastructure at a lower unit cost than even a large cloud provider. Obviously, the ratios can shift a little bit as, you know, various technologies like cloud management systems diffuse. You know, there are other issues as well. So, for example, a lot of the Newvem business model is oriented towards the fact around controlling and optimizing cloud spend, and not everyone, even at the, you know, if there are optimized unit costs, necessarily leverage those costs optimally. And so to the extent that companies are overpaying, their actual unit cost for service provider delivered cloud infrastructure can be much higher. And of course, the same thing can happen on their own, you know, behind the firewall in the enterprise data center costs. So this stuff is actually a lot trickier than it might seem, and it's not as simple as just, oh, cloud providers must be lower by definition because, you know, they implement best practices and so forth. So what that all says is it leads you to this set of equations. Nobody really likes looking at this set of equations, although, again, you can go to the white paper, which is online if you just Google mathematical proof of the inevitability of cloud computing, but it's much simpler to turn directly to the English. And what the English around those equations says is all other things being equal, by which I mean security concerns, behavioral economics, application migration costs, etc., then if cloud services cost less than your enterprise, then you obviously should use them. And by the way, you'd want to use them for 100% of your workload. If you can always get peaches for 10 cents a pound instead of $1 a pound, and they're the same peaches with the same freshness and the same quality, then why wouldn't you get them at a tenth the cost? On the other hand, if cloud services cost more on a unit cost basis than enterprise IT, then don't jump to conclusions as to whether to use them or not, because the key issue is that if demand is spikier than the cloud is costly, a pure cloud solution will cost less. Now, for a lot of people this is obvious, but for a lot of people it's not, and the best way I can think of to explain this point is through a rental car. If you're in a new city, well, let's first take the cost of a car. Getting your own car, whether financing it, paying cash and depreciating it, or leasing it, costs you, let's say, $300 a month. That works out to $10 a day. If you go to a rental car company and say, I'd like to pay $10 a day because that's what my own internal cost is, or better yet, hey, Avis or Hertz, you're a global world-class service provider that leverages best practices and advanced technologies. Therefore, I think I should get the car for $7 a day. Of course, they will laugh at you and or have you arrested if you persist. So what they would ask is that you pay $40 or $50 a day for that exact same car. And yet people happily pay $50 a day rather than $10 a day because, of course, the point is not that when you use it, $50 a day costs more than $10 a day. The point is that when you don't use it, $0 a day is a lot less than $10 a day. So if you have appropriately spiky demand, and that's these equations that I just showed around peak to average ratios being lower than the excess cost of the cloud, then it turns out that you should use a pure cloud solution. But as it happens, whenever there is variability and whenever there is any kind of cloud premium, it turns out that the best solution is to use a hybrid. Now, the caveat for that, which isn't shown here, is the very clever disclaimer on top, all other things being equal. If you need a $20 million network or have to pay, $5 million in data transfer costs to make a hybrid work, then the math shifts in favor of either pure enterprise or pure hybrid. If you've got to replicate data and incur a marginal cost for that data replication, then generally speaking, again, either a pure enterprise or pure cloud, pure public cloud makes sense. On the other hand, if you can account for that data replication on a BCDR basis, let's say, then the point shifts back to hybrid will win. So basically, the key point here is that rather than just saying hybrids are better or public cloud is better or private cloud is better, the point is that you need to understand your application profile. You need to understand your own ability to play around with that profile, including the ability to defer workload, the ability to do internal multiplexing of a variety of workloads, and the ability to take advantage of things like dynamic pricing through the cloud. And in any event, all those considerations will lead you to the economic optimum, beyond any strategic considerations you might consider. And so, assuming that hybrids are good, you end up then with some questions that look at things like the variety of hybrids that tie together users and enterprises in the cloud. And there are a few major generic hybrids, one of which might be called stateless elasticity, where you cloud burst from the enterprise data center into the cloud, but there's no need for data migration across them. or it's very limited. Another type might be a BCDR scenario where you're primarily connecting users up to the enterprise data center, but you're also replicating into the cloud, and the workload can shift over fully to the cloud using that replicated data with on-demand server resources to be able to enact a BCDR scenario. Yet another variation is where the cloud is the front end and the enterprise is the back end, where you have sort of content delivery, for example. And then the last is a full scenario with data integration and some ability to burst into the cloud. There are other scenarios that I cover, but these generically sort of set up what the network architecture is that's relevant for the cloud. And it also shows that while users probably connect to the cloud via the internet, any of those horizontal connections on the bottom of the triangle, of course, can use either VPN services or even lower layer things like fiber channel over Metro DWDM. And in fact, there are lots of different hybrids that can include a variety of legacy architectures that are kept in the enterprise data center, some that are not run on dynamically allocated virtualized resources, pure private clouds. Some of that customer legacy equipment moved into a co-location facility, those that are traditional managed services, hosted private cloud, full public cloud, and ultimately I think we're starting to enter the era of the intercloud in a variety of different frameworks, including dynamic switching between a variety of cloud providers, which I think Newvem is going to really help facilitate, as well as things like the IEEE intercloud effort and various other standards bodies that are looking at that. As far as kind of critical reasons for using the cloud, one of the key ones is spikiness. A good example is NBCOlympics.com, where they had it's greater than a 10,000 to 1. It might even be a 1,000,000 to 1 type of ratio between peak to average. Of course, it's very hard to provision an enormous amount of resources privately, not use them, and then say, okay, we're going to use them for basically 2 weeks or maybe a month every couple of years. So using a public cloud or doing some internal workload multiplexing makes a lot of sense. And this is a simple thought experiment showing the smoothing effect that happens when you take independent, identically distributed workloads that are uniformly distributed, which is a simplification just to show how this works out. As I move to 4 workloads, it looks like that. As I look to 25, as I look to 100, then you end up with workload smoothing as well as utilization enhancements. And this means that anyone that can multiplex workloads, whether it's a enterprise with a sufficiently diversified set of applications or a public cloud provider, can achieve these kinds of statistical multiplexing benefits, which some might call, or you might call, the statistics of scale. And what it means when you look at the curve is actually the companies don't need to be very large to start achieving a lion's share of the benefits. So for example, if you mux 2 workloads, you end up with a 30% relative penalty cost reduction. At 100 workloads, you can get to within 10% of the theoretical maximum of a world-class provider. Again, caveats there are, key assumption is that the workloads are independent. If you basically, do nothing for 11 months and then everything in your company, including ordering systems and credit card validation and e-commerce and everything else goes crazy, you're not going to get a big advantage by multiplexing those correlated workloads together. One other thing that I think is interesting is this is a little bit of a theoretical result that shows some of the interesting things that Newvem is doing as they go forward with some of their services. And this morning they announced support for Azure in addition to their prior support to AWS. And so as you look at optimizing prices across clouds, if you assume that You have a uniform distribution of prices, but that they are variable. So, particular providers may offer things like spot pricing for resources. Then the expected value for a single provider, let's say if the price simply were to go from vary between 0 and 1, is 0.5 at any, that's the expected value of the price over time. But if you have two providers, it turns out that you end up with a 34% improvement from 0.5 down to 0.333, and this is based on the theory of order statistics, which is the expected value of the minimum for distributions taken from a particular sample size. And so the more and more providers that you can choose from, again, assuming their prices are varying dynamically, you end up with, again, diminishing returns, but nevertheless, some pretty important reductions in spend. So I think that that covers things. I've got other things that I could cover around cloud response time and some of the math behind that and demand, but I won't get into that. Instead, I think what I'll do is just say thank you for listening. Hopefully some of you found at least part of that relevant, either on the strategy side or on the statistics side. I didn't get into anything like behavioral economics. It's kind of a rich field, is moving out of the specific aspects of which companies do what where and getting into sort of more abstractly what exactly is going on as far as why would you use the cloud, what are the benefits, and they're a lot more than cost and agility. I think ultimately they tie right into the strategy of the firm. So with that, I'll stop talking, and I think we're opening up to questions or something or other.
Yeah, absolutely. Thank you, Joe. Thanks very much for that for the presentation. I guess I really want to get into maybe some questions first. Our friends at Newvem have been curating those, and I've got a couple of my own, of course, from your presentation. Maybe first, let's take a high-level example, and maybe I can pick your brain a little bit about that. Just to keep things simple or straightforward, let's take an organization maybe that isn't, their primary product or service isn't technology, sort of that classic, XYZ widget maker company. If their focus, isn't primarily technology, yet they feel the same pain and pressure that most organizations do from an IT perspective in terms of, things like infrastructure procurement, staffing challenges, budget challenges, that sort of thing. Through your work, quantifying sort of the cloud, the economics behind cloud, what is, or is it even possible to sort of summarize what the correct operating environment for a company like that is? And then, correct's not maybe the exact right word, but what's some of the optimal things that they could do looking at their IT spend in terms of, being as efficient as possible?
So I could probably do a whole webinar just on that, but just to relate back to some of the things that I covered. I would say a few things come to mind, one of which is there's a great post out there that I think is something that we all know, but it sums it up pretty well, which is Mark Andreessen's post called "Software is Eating the World." And the basic point is that if you look across virtually any industry, it's increasingly becoming a digital business in one way or another. And that's true not just of digital native or cloud native businesses like a Google, Facebook, or Amazon, but pretty much anything, right? So, financial businesses that used to be, open outcry in the pits, are now obviously, high frequency and algorithmic trading. If you look at manufacturing businesses, you've got the importance of CAD and, open innovation early in the design process and, online ordering. If you look at hospitality, everything's changing from online kiosks for check-in to, online check-in to, use of mobile phones, mobile wallets. So, it's obvious, I think, to everyone, maybe that's on this call, that every industry is becoming increasingly digital and informationalized. So that said, IT is more important than ever before. And if IT is important, then the question is, strategically, how do you best leverage IT? And, I think I sort of alluded to, some of the ways that tie in perhaps to firm strategy. So, the way you leverage IT if your business model is operational excellence is probably different than the way you would leverage it if your business model is customer intimacy. But IT is certainly important. And then use of the cloud can be a very low-level tactical cost optimization or business agility play. But I think there are also lots of things that people don't tend to cover that ultimately are sort of cloud-native solutions. And a good example of that is open innovation for accelerated innovation through cloud. So, for example, a few weeks ago, the Netflix Cloud Prize, where I'm a judge, was announced. And the interesting thing about that is, I love what Netflix did there because it's, innovation in terms of their own infrastructure, but the model which they originally used for the Netflix prize, which was improvements to their Cinematch algorithm, they applied that as well as they're letting it be done through improvements to, sort of open source code that helps in a variety of cloud areas, including reliability and performance and chaos monkeys and things like that. So anybody can do that and leverage the cloud for innovation. A good example of an old line company is Procter & Gamble with their Connect and Develop open innovation platform. So, anybody on this call could invent the next diaper or, toilet paper or whatever, shampoo, and basically, that's a model that is mediated via IT in the cloud. So
sure.
Probably a long answer to a short question, but
yeah, no, that's great. That makes a lot of sense, and I think, I think you answered this next question through your presentation, but maybe a summary would be good. We have a question from our audience. What model is most cost-effective when you look at, the option A, one of the best cloud providers you can find, one who scales the best, one who meets your business demands, or multiples? And I think you talked about the reality of intercloud in the context of the hybrid discussion you went through. Maybe we're getting close today. Is there a more cost-effective choice, or is it a little more complicated than a yes/no answer?
It's probably more complicated. I mean, I think the thing to do generally is, it's clear who the leaders out there, and so it depends on what your need is, right? If you're, obviously well-known use cases, Netflix leveraging Amazon Web Services, and, if you were someone like that, it would be hard for you to leverage, let's say, a very small, regional cloud provider, given that you have a global presence. On the other hand, if you were looking at, let's say, ultra-high performance for some type of workload, then maybe having someone that's got more of an architecture with, guaranteed IOPS and, leveraging SSD drives and things like that might be very relevant. If you're looking to leverage some sort of high availability, but you've already got everything in your own enterprise data center, it might make sense to have more of a hosted private cloud in a co-location facility that's within your metro so that you can cost-effectively synchronously mirror your data over to that facility and kill both the BCDR solution as far as a zero RPO for your data, in other words, no data loss, coupled with some elasticity in that hosted private cloud for a very rapid BCDR while minimizing data transport costs for data-intensive applications. So I'm not sure that there is a one-size-fits-all solution. I would say that for many companies, they've just got to look at what is their overall business strategy, how does that tie into their IT strategy, how does that relate to their cloud strategy when thinking about the importance of cost optimization versus other concerns like security, like data replication, like elasticity, and like regional availability. So I hate to keep picking on Netflix, but I just find them doing a lot of the cool stuff out there. And so one of the things that they did a couple of weeks ago, for example, was they actually deliberately, did no, this is not a chaos monkey. I think it's been referred to as a chaos gorilla, where they actually took out the eastern region to make sure that their failover to the western region worked. And of course, they had some issues based on simple availability zone failover that caused the loss of some services on Christmas Eve in some regions on some devices. And so they just recently fixed that and tested that by having a multi-region rather than simply a multi-availability zone failover. So I think that you have various degrees of what's your application, what are your needs, and therefore which public or private cloud solution might be optimal for that. And then you also have the emerging reality of both cloud bursting and ultimately of intercloud solutions, where there will be further failover possible. And there's obviously in other businesses, which I consider clouds as well, like hotel chains, the same models, right? If you're usually a Marriott customer, but the Marriott in the city you want to be is filled up, then you go to a Hyatt, or DoubleTree or whatever. And so your ability to use a cloud broker like your online travel site to select from across multiple cloud providers is something that you do without thinking. And actually, even an intercloud reinsurance model is also, applicable in that domain, where as you go to check in, they say, we're so sorry, we had a glitch, we're overbooked, and, we're going to put you up at this competing hotel that's just a block away. So, all those models exist elsewhere, and it's, to my mind, just a matter of time before they're all as easy to use within a public cloud context. And that, obviously it's a little bit easier to check into a different hotel than to, deal with API considerations, but there are lots of well-known approaches, like wrappers and transcoding and, file format conversion and, open VM standards and you name it that will help facilitate all that. So, it's not a matter of if, but when.
Sure. Yeah, that makes total sense. We have probably time for one final question that comes from our audience again, and this is they're looking for some clarification around what stateless elasticity hybrid cloud model is all about.
I have no idea, but it just sounded cool on the slide. What I meant by that was, first of all, elasticity in the sense specifically of cloud bursting. So I'm in my own enterprise data center, and then I invoke and deploy, provision additional servers in a public cloud. Now, that all sounds good. The question is, if I have a petabyte of data in my enterprise data center, it doesn't really help me to have servers in the public cloud unless the service that I'm now running can actually access that data. Now, several ways to do that, including remote data access, partitioning the data, pre-synchronously mirroring it or replicating it into the cloud so it's there as I start spinning up those servers. But it's even simpler if my application is completely stateless or essentially stateless. And so an example of that that comes to mind is Animoto, where, for example, they were able to scale up, but what they're doing is you are providing some photographs to an Animoto server. They're then converting those photographs into a video, and they're returning the video to you. So the data intensity is between the user and the service, and it doesn't matter where that service is located. You could also consider something like Google search, where there's really, no matter how many nodes the query index is deployed across, it can still respond to search results, and it doesn't matter what kind of elasticity there is in terms of various servers and routing queries to those servers. there's no inter-node traffic that's really required. So that's what I meant by stateless elasticity. It's very different than, let's say, a bank where you've got to have account state and know the balance in every account before you can respond to, let's say, ATM transactions or debit card withdrawals, et cetera. So, that's what I meant by that model. I talk more about it in the book, but, the basic point is that you can't just look at cloud bursting and say, oh, yeah, a Cloud OS or a management system capability will let me do that because it's trivial to spin up servers. The hard part is then dealing with the data.
Yeah, absolutely. The whole notion of this notion of data gravity comes into play as well in terms of where your app runs and where your data lives, and trying to get those things as close together. Perfect. Well, I think that's probably all the time we have today. I want to thank everyone for participating. Just before we break, my friends at Newvem and I are really excited about some new functionality released just today. I think Joe made reference to it in his presentation as well. That same great functionality you've grown to know and love as it applies to AWS is now available on Azure as of today over at Newvem. So please visit Newvem, and they'd love for you to sign up and evaluate it and see it for yourself. With that, thanks very much to Joe and, of course, the audience for tuning in and spending the better part of an hour with us today. I think next in our series, in about a month's time, will be a focus on high availability, and we sure hope you'll join us again. Thanks, and have a great day. Thanks, Joe.
Hey, thank you, Patrick.